Helping my crew is what I do.
When it comes to problem solving, students are empowered to think about things and find a solution for themselves.
Problem solving is fun because I get to learn different strategies and then I get to learn what they're thinking.
And the teacher's job is more to question, to guide, to help them come up with the answer on their own.
I don't care if it was right or wrong. Give me a thumbs up if you tried something new.
It feels great to share in front of everybody, and the people that are sharing, it's like you're learning from them. And then when you get to teach the people that taught you, then they can learn from what you did.
I love to see when they catch, when they do something wrong. That means that your mind is growing and you're thinking.
Sometimes I get things wrong, that's okay, and then I just correct myself and then I just be better than yesterday.
Kiss your brain because guess what? You grew your brain today and you should feel very, very proud of yourself.
There's two people whose thinking I saw that I really want to feature today because I think it's going to help move everybody's thinking along. So those friends already know who they are. They're going to meet on the carpet. Everybody else, leave your things here and come meet me on the perimeter in a smart choice spot, please. Thank you.
The main goal of the math work today was to push students thinking forward from that base 10 direct model strategy into something else.
While Jenais and Destin are sharing, and while we're putting up here what they did, I want you to be thinking about how is their work the same. So I'm gonna start with Jenais. Go ahead, Jenais, what did you do first? How did you put 34?
A minor goal was to build access for the students that didn't have it. So I shared Jennais's work to try to build access for those kids who still aren't quite understanding those change unknown problems.
And then what did you do next? So 65.
66, 67.
So you watch what Jenais did. Now you're gonna watch what Destin did. And you're thinking about, what are we thinking about?
What Destin and Johnny do the same.
What they did that was the same. Noah, I wonder if you can tell us what they did that was the same. Oh, Destin, what did you do?
So the tens that I added, I counted them, and then I added my 8.
So you counted 10, 20, 30, 8. So it's right here in the middle what you added.
So while I was charting the students' work, the students were to be thinking about what do I see that was the same.
Right, I want you to take a look at Jennais's work here. And I want you to take a look at Destin's work. What did they do that was the same? In a second, I'm gonna have you turn and talk to your partner, and it might sound like this. Destin and Jennais both. And I want you to see if you can come up with more than one thing that they did that was the same. Okay, so I want you to keep chatting. I'm gonna have Ethan and Brendan need an eye to eye, Cameron and Noah.
I see what they both did is
I was listening in during that turn and talk after the share just to see who kind of thought a little bit deeper about that than just the obvious. So I was looking for someone to say they both added on by tens in different ways.
Deontay, I think I overheard you say something that was interesting. What did they both do that was the same? What did they do that was the same? They kept adding tens. How did Jennais add tens?
She added 10, but she added 10 just by one stick.
Okay, and how did Destin add tens?
She added 10 just by added 10 to that. You can see the 38.
Oh, he just added the number 10? Oh, interesting, okay. All right, crew, turn back to me in 3, 2, and 1. What did they do that was the same? Okay, remember, we're gonna start with one friend. They're gonna pass it on to somebody with their thumbs on their knee, okay?
And I also think it's super engaging for the students to call on each other during the discourse. It's not coming from me, but it's coming from them. They know if they're sitting up like with their thumbs on their knees, they might get called on. And if they're not, their friends aren't gonna call on them. And I feel like that peer relationship thing kind of keeps them more engaged because they want their friends to call on them so they can talk.
I'm gonna start with Deontay. Deontay, what did they do that was the same?
What they did with the same is they kept adding to.
Deontay was introducing the way that both strategies were the same. I knew not every student was going to be able to see that adding a stick of 10 and adding that 10 number, how they like correlated. So I tried to anchor that on the chart so students could visually see the connection between those things.
She counted 44, Destin counted 44. She counted 54, Destin counted 54. She counted 64, Destin counted 64. She added 8 ones. He added the 8 ones with his fingers. Interesting. Does anybody else see what Summer sees? See those similarities? Can you see that, Ethan?
Silent cues are super important. Kids will go like this, me too, if they agree with something. They'll kind of go like this, like I have a question or I disagree with you. So I can see and their friends can see they're thinking without interrupting and like making it a loud explosion of ideas at the same time. And that definitely keeps kids engaged.
So I'm wondering, does it matter if we use 10s and 1s or if we use number sentences? Does it matter? I want you to turn and talk to your partner. Can you use both ways?
That they subtract did the same way. They both did it the same way. But Dustin counted his fingers and Jenna.
I believe the goal was met, and I feel like I know that through the discussion. As the students were talking, I was listening in, and most of them seemed to understand the connection between the base 10 model and the invented algorithm model.
We can use each strategy because Destin's way is faster and Janae's one is faster. But Destin was more efficient.
Why was Destin's way more efficient?
He only just used number sentences.
So you're saying that if you're just using the numbers, you might get the answer a little bit faster?
Some students are stuck always using the same strategy, and I loved that Summer said that Destin's was more efficient. So although they both got the same answer, like that might be a motivator for kids to try something new the next time.
I am so excited because guess what? Tomorrow, we're gonna do another problem and I cannot wait to see. Did you learn something from Destin? Did you learn something from Jenais? Could you show multiple strategies? Do you have a new way to show us and to blow Noah's mind tomorrow? I cannot wait to see that.